Hi Year 13, in this video we're looking at the new level 3 class of compounds known as carboxylic acid derivatives. And that encompasses 3 specific compounds: acid, chlorides, esters, and amides. Now carboxylic acid derivatives, well, carboxylic acid looks like this, goes at the end of a chain. The derivative has the same carbonyl, but where the OH is, it has something else. Okay, and that's why it's called a derivative. It's made from an acid, and it's very similar to an acid. Okay, so the other thing to point out is when we name it, it's always the most important thing. It's always going to be the end of our chain, and it's always going to have position 1 for its carbon for all of our different molecules. All right, let's start off. Acid chlorides. So acid chlorides is simply the Cl is replacing the OH. Okay, its suffix name is anoyl chloride. So if I have one carbon with a Cl, that is known as meth for one carbon, anoyl chloride. And you'll see there is a nice juicy space there. There is a space there between the anoyl and the chloride. Okay, and I'll do another. We could do with like 4 carbons, the end of the chain, Cl, and this would be butanoyl chloride. Okay, now if you adjusted that with a side group, let's say we put a methyl group on this position here. We get rid of one of those H's. Okay, this would be methyl butanoyl chloride, but it needs a position number. And because this is 1 always, then that's 2 and that's 3. This will be 3-methyl butanoyl chloride. Hope that makes sense. Okay, our second carboxylic acid derivative, it's a little bit more complicated, is esters. Esters have 2 groups. Okay, and obviously that bit there is replacing the bit from the OH, or the H really. Okay, and the R1 here is the original carboxylic acid. So it can be thought of as a carboxylic acid, and this is how we make it. For example, ethanoic acid, and an alcohol, for example, methanol. And basically what happens is you take the H2O, and you'll learn a little bit more about this later, get rid of that, and you get your original carboxylic acid with OCH3. Okay, so that's an ester. It has an 8, instead of the H, it has some kind of carbon chain. Okay, and how we name it. Well, the name has an anoate ending, but that's to do with this thing. So whatever carboxylic acid you had, if it was ethanoic acid, it's going to be ethanoate. So the first part of the naming is quite simple. Whatever the carboxylic acid should be, you name it noate. Instead of noic acid, you name it noate. Okay, the second part is we're going to have a nice juicy space. There's a space there, that's not a hyphen. There's a space there. And we're going to name whatever this is, space. And we're going to name it like a side group, just like any other side group. So we're going to have methyl space ethanoate. Okay, so this can get a little bit more complicated. Let's try something a little bit more edgy. Okay, we can have something with a Cl, for example, and an H, and then O, and then we can have CH2, CH3. Okay, so this here is from our alcohol, and originally that's ethyl. Over here we have a Cl, so that's a chloro. So that's going to be an ethyl space chloro, but it's going to be 2 chloro, and it was propanoic acid, so it's going to be propanoate. Okay, so ethyl space 2-chloropropanoate. And just to show you how confusing it can be, but if you're careful, it's not, you can have this. You can have, let's do 4 carbons, just for fun. Sure you're all laughing at home. So, and then we can do, again, let's do 2 carbons again. You could do 3 carbons, that'd be propyl. But this is 2 carbons, it's ethyl. So we're going to call that ethyl. Over here we have a methyl group. But it's on position 1, 2, 3, so that's 3-methyl. Okay, so our name is going to be ethyl with a space. 3-methyl butanoate. And again, this would be, over here, 3-methyl butanoic acid. So that's 3-methyl butanoate. And then I chuck the ethyl group in front. So it's ethyl space 3-methyl butanoate. Okay, and the last one is amides. In amides, we have these R groups. You're going to be drawing those as products, but you're not going to be drawing them from names, and you're not going to be naming them. For naming purposes, you're going to be doing that with NH2. Okay? It's going to make things a lot easier when it comes to naming. So when we draw and name it, say we do something like this. Going to have the same classic 3 carbons. So that's going to be pro. And it's very similar to amine. So amine would be propanamine. This is propanamide. Now there's a distinction here. Amines have a position number to tell you what place they are, but just like any carboxylic acid derivative, it's always position 1. So it's never going to have the number written down. It's just going to be part of the name. Okay, but if I was to put in, let's say, my favorite, an iodine. Okay, so say an iodine there. That's going to be position 1, 2, 3. So it's going to be 3-iodopropanamide. Okay, there are ways of naming it when there are other things on here. It's just not going to be assessed. You might see it from time to time in your exams. At any rate, those are the 3 new carboxylic acids derivatives for this topic. I hope that was informative. Until next time, guys.